Hi, this is Daryl Barnes with BarnesBasics, and with the holiday season approaching, I thought we would work in some kinematics problems that kind of relate to the holiday season. With his air rifle, he aims at a mistletoe in the tree out in the country. He misses the branch and the pellet continues straight vertically. The barrel velocity of the pellet rifle, the air rifle, is 600 feet per second. I want to convert that to meters per second. And then the next question is, neglecting air resistance, how far does the pellet rise? And so we're going to be looking at some new information here, and might get kind of squeezed as we go, but let's do this. One of the things that I want you to know is that there are 3.28 feet in 1 meter. So if we want to convert from feet per second to meters per second, we just cancel feet over feet. We're going to take 600 divided by 3.28, and we'll get a meter per second value that we can use in our kinematics calculations. In the very first video of this play series, I describe how to make sure that your TI-84 Plus is set for normal, fix 6, dec, real, degree, and math print. And I also described how to set your Nspire cast to float 6, degree, normal, and approximate. And just quickly, I would say that if you turn your TI-84 on and hit mode, then you can use your nav pad to go through and select all of these values. Hit second and quit to get out of that. And when you are in a math document on your TI-Nspire, what you would do is hit home and then pick the multiply, divide, minus, plus key at the bottom and click on that. And once you do that, then go back, let's go back home and let's go to settings 5, click on document settings, and it will give you a list of settings that can be applied. Pick float 6, degree, normal, approximate. Go through these and click on each one with the center button of your nav pad if you need to, and then at the very end tab all the way down to OK and click on that to apply it. I already have mine applied, so I'm going to go back to my bottom left document for math and click on that, and by now I'm up to document page 1.5. That's okay. By the way, if I wanted to go between document pages, I would just hit Control and left, Control and left, Control and left to go back to whatever page, whatever tab I'm looking for. Tab 1.3 is empty, so I'm just going to go right there. That'll work. So to solve this problem, 600 divided by 3.28, let's go 600.0 divided by 3.28. Let's hit enter. And I get 182.92. Let's go with 4 sig figs. This has 4 sig figs. We have one whole number and then 4 zeros to the right of a whole number associated with a decimal. So let's go with 182 point, it's 92, but the 2 is not going to make that 9 go up, so we're going to leave it as 182.9 meters per second. And one of the interesting things that we kind of need to get associated with is this is an upward velocity, and so we're going to go ahead and give it a value of positive because we're going to bring in a new variable, gravity, which acts downward. It doesn't matter if an object is moving up or down, it's acting downward, and it has a value of negative 9.81 meters per second squared. So why don't we find a spot? Let's say that gravity is equal to negative 9.81 meters per second squared. We're going to be talking about that, and that, by the way, can be substituted for acceleration in our equations. Let's do this problem in the TI-Nspire. 600.0 divided by 3.28. Enter, and I get 182.927. That's perfect. So for the first part, for the first question, I went from feet to meters per second. I didn't write that out because I'm kind of running short on space, but I'll go ahead and circle that since that is actually my first question. And the next question, it says, neglecting air resistance, how far does the pellet rise? Remember that when we do these physics problems, we're working in ideal situations, and we don't have a lack of air resistance here on our planet, which is a good thing for us because we need that to breathe. But that's what we're going to use. This is kind of an important thing to remember. So the formula that we're going to use for D is going to reflect the values that we're given here. We know that the initial velocity VI is equal to plus 182.9 meters per second. Now, here's another important thing to remember. When pellets or any projectile goes up, it actually goes to zero and it stops for just a second before it starts falling back down. So VF would equal to 0 meters per second. We have introduced just a second ago that acceleration is equal to negative 9.81 meters per second squared. We know that. And so these are the values that we have. And just to kind of make this jive, it doesn't really make them significant to do that, but we'll just do like that. If we took the formula VF squared is equal to VI squared plus 2AD, if we took that formula, if we take this formula, then we can solve for D. And let's do that real quick. Let's subtract VI from both sides. We're going to flip this around in just a minute. Not yet. I'll go real easy. Let's go. VF squared is equal to VI squared plus 2AD. Let's subtract VI squared from both sides. That's a negative value there. That cancels. Then we would have 2AD is equal to VF squared minus VI squared. Why don't we divide both sides by 2A? 2A, and that gives us the final working equation. D is equal to VF squared minus VI squared plus 2 times acceleration. So when we plug these values into our equation, we would say that D, let's kind of come right up here, let's say D is equal to VF squared, which in our case is going to be 0. This pellet goes up and it stops before it starts falling down. That is going to be 0 meters per second squared. And that's going to cancel out. We're going to subtract a positive 182.9 meters per second squared. So let's go 182.9 meters per second. Let's square that. We're going to divide it by 2 times the acceleration due to gravity. We learned just a minute ago that we can use negative 9.81 meters per second squared on the bottom. And so let's see if we can solve this. This is going to drop out because 0 squared is 0. So this is a little bit tricky, so pay close attention as I go through. We've got to get this negative in front and this negative in front. It is the bottom right negative right here where we have answer. On both calculators, it's at the bottom right. That's how to put a negative in front. Now, here we go. Here, hit on for the TI-84, hit clear. To get this negative in front, we're going to hit on and clear, and we're going to say negative, open parentheses, 182.9, and we're going to close the parentheses, and we're going to hit x squared, hit enter, and we get negative 33,452.4. That's roughly what we get. We're going to divide by 2. Divided by 2. Enter. Okay, I get negative 16,726. Okay, divided by negative 9.81. Enter. And I get 1705 meters. We're going to circle that right there because that is the correct answer. When we get the answer of positive 1705 in these problems that relate to gravity, it's important to go ahead and put the positive sign in front of that to show that that is an upward rise. And this is an upward velocity, just in the same way that gravity always acts downward. That just makes everything a little bit easier to grasp inside of the brain cell. In the TI-Nspire, let's hit on. Let's go. We've got our page up already. Let's say 180. Let's say negative, which is at the bottom right of the keypad, negative, and then let's do an open parentheses, which is at the bottom left, 182.9. Let's close the parentheses and hit x squared. Let's hit enter. I get negative 33,452.4. Perfect. Divided by 2 and hit enter. I get negative 16,726 divided by negative 9.81, enter, and I get 1705.2. Now I had 4 sig figs here. I have 4 sig figs in my answer. Everything is groovy. Everything is cool. Couple of things I would like to say. The minus sign is over on the right side of the keypad. That's not the minus we're using. We're using the one that's right below answer. Same thing on both calculators. The minus is at the right, but the negative is at the bottom. If you need to, go back and review it. Marvelous. Very good. When we get the answer of positive 1705 in these problems that relate to gravity, it's important to go ahead and put the positive sign in front of that to show that that is an upward rise. And this is an upward velocity, just in the same way that gravity always acts downward. That just makes everything a little bit easier to grasp inside of the brain cell.